Welcome back. In this video, we'll go through the preliminary index laws. You should be familiar with these laws from GCSE or IGCSE or any other qualifications that you have in mathematics. But let's go through them again just to consolidate your understanding. The reason we add the powers is because here in this expression you have x times x, and in the next term you have x repeated 5 times. So how many x's will you be multiplying on this line here? You say x to the power of 2, x to the power of 5, together the powers add up to 7. So that's why you write the answer x to the power of 7. Again, in this next exercise, you have to answer a few questions. So let me get rid of my writing there. In the next part B, you have 2 times r squared and 3 times r cubed. Make sure you take the coefficients. Here you do multiply the coefficient 2 and 3, but you add the powers. So this 2 and this 3 you multiply, get 6, but these 2 and this 3 you add to get power of 5. Okay, so in the next expression you would have 7 b's on top of the fraction, so b times b times b times b, like so, and you would have 4 b's in the denominator, so these would cancel away and these would cancel away. So we will end up with 3 b's on top of the numerator. Therefore, you write b cubed. So when you have 6x to the power of 5, divide by 3x cubed. 6 and the 3 divide to give you 2, and 5 minus 3 will give you 2 as well. In this next expression, you have to first evaluate this power here. So this means that a cubed is multiplied by a cubed again. So the fact that you have two lots of powers of 3 means that you can multiply 2 by 3, and you would end up with a to the power of 6. Then next expression, or rather the next term, is easy. So here we bring down 2, we write the coefficient first, and then we add the powers, and we end up with a to the power of 8. Okay, so let's look at the next exercise. Here we're dividing the 3 to the power of x squared, which is cubed, by x to the power of 4. So first we simplify the powers of the first part of this expression here. 3 to the power of 3 give you 27. So here, if you do have a coefficient, you do need to distribute the powers into each of those terms of the bracket. So because they are multiplied, you can do this. This doesn't work if there's a plus sign or a minus sign. So don't confuse it with this. If I had a plus b raised to the power of 3, I couldn't distribute the power because of the plus sign. But I can do that only if there is no sign, or rather just the multiplication or division sign inside the bracket. So this doesn't work in the same way, but 3 times 3 of course give us power of 6 here, and then you evaluate 6 minus 4 will give us x to the power of 2 on the top. Now if you have an expression such that here you have a 3a over 2b, and then you also have a power of, let's say, 5, this time, yes, you can distribute the power here, and you need to distribute the power for each part of the denominator. So you would have 3 to the power of 5, a to the power of 5, divided by 2 to the power of 5 times by b to the power of 5. Alright, so let's look at the next question. Here, you've been asked to expand brackets, so you simply multiply each term across the bracket. So negative 3 times 7 is negative 21, x times x is x squared, and negative times a negative 4 give us negative 12, and the x comes from the outside of the bracket. So pause the video, have a go, and then play. Alright, so first term is 3y to the power of 2, negative 2y to the power of 5, and so on. So if you have more terms inside the bracket, that means you would have to multiply the 4x by each and every one of them. Because the powers here are different, you cannot simplify the expression inside the bracket. So the final answer would have 3 terms, which is like so. Alright, this next expression, you can multiply the bracket and try to simplify it after you multiply it after brackets. You'll get 10x to the power of 2 plus 6x minus 10x minus 15. Now make sure when you multiply 3 and 5, you also take the sign of 5 with it. Now the two terms in the middle of this expression will add up to each other to give us minus 4x. The first and last term remain unchanged. Okay, so think carefully. To simplify this expression, first you can factorize x to the power of, what would you factorize out of the top of the numerator? X to the power of 4 is a common factor, so you would factorize that out, or write it like so. So one way to think about it is writing x to the power of 4, x to the power of 3 plus 1, and then divide x to the power of 4 by x cubed in the denominator. That would leave 1x on the top behind. So that would be x multiplied by this bracket again. So then now you can multiply back this x into the bracket and get x power of 4 plus x. Or another way to think about it is to split up the fraction into two fractions. We would have written it like x to the power of 7 over 3 plus x to the power of 4 over x to the power of 3. So then you simplify each fraction separately, and you end up with the same answer that we've got here. X to the power of 4 and x to the power of 1. Now I'm going to remove that and yeah, have got the next exercise here. So then here, once again, you can split the fraction into two fractions. This is only allowed when you have one single term for the denominator. But don't do this. If you have, for example, x squared plus x in the denominator, and you have two terms on the top, you cannot separate the denominator. This plus sign means that this expression must stay intact. You cannot have 3x squared minus 6x to the power of 5 and write it like 3x squared over x squared plus minus 6x to the power of 5 over x. Don't do this. This is a mistake that some students make, because this denominator is like so, you have to keep it intact. Alright, so let's have a look at this expression here. So we'll split it up first, and then we'll simplify the common factors. Now 6 and 2 divide and give you negative 3. With the negative comes up from the fraction outside of the fraction. So we'll end up with x to the power of 4 and so on. Have we got this next example on here and then play the video. Alright, so happy practicing exercise 1A. As I said, it's highly recommended that you have a go at least every other question or every third part of this exercise. So have a go at this column here maybe, or the middle column or the last column, and do A, C, E of each question, because you want to ace your exam. So have a go at those questions and then check your answers with the back of the book. And if you're unsure about anything, go back and ask your friends or check out the videos again.